You know what? Why don't we kick it off with get your 6 GHz configuration right with Ekahau.
Yeah, so massively thank you, Stu, for introducing and getting that all sorted for us for the webinar. And we are extremely excited to be here with you today to continue on with our Summer of 6E webinar series. And like Stu just said, we are continuing on the webinar series with this one is to get your 6 GHz configuration right with Ekahau. And, you know, we can see the surfer dude, he's catching that new wave. And I thought, well, you know what, I've just got to get myself one of these wavy shirts so I can really embrace and get into the spirit of our Summer of 6E. So Stu, where is your?
But I just, you know what? I just a habit of putting that on. I think you hold that thought.
Okay, I'll hold that thought. No worries. All right, well, let's kick off today then. So who have we got here? So you've got myself as the Director of Product Marketing and ECSE, and your favorite psychic, Stu, and Mac. Oh no, where is Mac? Unfortunately, Mac is a little bit under the weather today, so he's unable to join us, unfortunately. And we know this must be killing him because he's always crying from happiness when he's here on our webinars. But I really guess that all of those sleepless nights from the excitement that where he couldn't sleep has caught up with him and he's just not able to join us. So wishing you all the best, Mac, and we know you'll be here back with us very soon. So yeah. So on today's webinar, first of all, just a little bit of a recap. The previous webinar that we did was around how you can design for your 6 GHz wireless networks, which was on our previous webinar. So if you've missed that, make sure you go and catch it because that was a really, really good one. But you know, at Ekahau, we really want to make great Wi-Fi more easier and accessible for everyone. And we have our 3 steps to great Wi-Fi every day. And in our previous webinar, we really focused on those first 2 kind of sub-bullets of step 1. You know, with a great network starts with a great design. But how do we get to a great design? Is it getting your requirements in order? Then we've got to get the right number of access points in the right locations, which we covered all in that previous webinar. So what are we focusing on today? And well, we are finishing up today with the final sub-bullet of this slide with the right configurations. With 6 GHz, there is a lot of additional features for us to think about and to understand to help you get the right configurations for your access points, for your designs, and for your deployment. So that is going to be kind of like rounding off step 1 of our 3 steps to great Wi-Fi. And then we have our step 2 to great Wi-Fi every day. And on step 2, we talk about validating. So we use our psychic to validate to get the super accurate measurements. But how are we going to be validating our 6 GHz wireless designs, Stu?
I don't know. I'm you stopped me on the last couple of slides. It's like, where's he going with this one? Is that and this guy here? How are we going to do it?
Well, I think if you really want to know, you're going to just have to sign up to our next upcoming webinar where we are going to be unboxing the future of Wi-Fi, where we will be able to measure the future of Wi-Fi. So please do me a favor, pull out your phones, scan that QR code and get yourself registered for the upcoming webinar. It's going to be a great one. And I'm sure you're going to be extremely excited to be there for joining us for the unboxing. So please make sure you scan that QR code and get yourselves registered.
Absolutely. Do that now. We'll never know another 10 more seconds on that because get that in there. Go register right now while we're on it. You'll be able to catch up quickly. But Matt is right. He's so excited right now. He can't contain it. I mean, for me, it's like, man, there's so much to share. But
just gonna have to sign up. And if you've missed the QR code now, we will put the QR code back up at the end of the webinar today. So let's crack on then. And on our last webinar, we were talking about some of the new things we have to think about and consider. And when it comes to 6 GHz, we have this thing that's called the AFC, which are the automated frequency coordination. And this basically is for our standard power access points where we're using a particular subset of the 6 GHz channel. So depending on where you are in the world, so in the US, for example, this affects your unibands 5 and 7. They are required to use AFC outdoors. Also, because we've got Stu here and a lot of our Canadian friends, Uni 6 is also available in Canada. So what what is the role of the AFC and what does that mean for our wireless access points? And well, the AFC uses geolocated databases to manage real-time frequency allocations. And the reason why they are here is to protect the previous incumbents that are using the same frequency band. So the standard power access points, they check in and they make sure they're not going to be interfering with any of the previous incumbents, which is mainly satellites and TV broadcasters. So outdoor access points, they must be able to locate themselves with GPS or another form of method. So the AP will send its 3D location, including the height of the antenna, and then it has to go to the AFC before it's allowed to transmit. So the AFC will basically do some checks to make sure it's not going to interfere with anything else in the area before it can start transmitting. So little story here, I'll pretend I'm the access point, I'm the standard power access point. I'm going to say, hey, I'm a standard power access point. I'm located on these geo locations, and I've got my antenna, which is a 21 dBi gain, and it's elevated to 12 meters high, and it's facing north. What channel and transmit power can I use? The AFC provider is going to be like, hey man, since there are active wireless incumbents already in this area, occupying that entire Uni 5 band, and you'll probably interfere with them, use Uni 7 on channel 129 and ensure your maximum EIRP doesn't exceed 30 dBm. So that is the role of the AFC providers.
And it just
Sure,
helps
go
out
ahead.
a lot more, right? Like it's going to help us be better friends in the RF environment, one route in the field. Because you know, Matt, when we were, remember the old days, we were planning 5 gigahertz, we couldn't use it in certain countries, or maybe we were doing global deployments. It was kind of complex, and this kind of helps us along that journey,
Oh, 100% for sure.
right?
So yeah, and and unfortunately, Wi-Fi isn't the first technology to be working there. It doesn't get that priority. So we have to just make sure we play nicely with everyone, and this is how we're going to be doing that. So let's move on then, and let's talk about channel widths and this new concept as well that's called the power spectral density, or PSD. And let's just discuss actually what happened prior to 6E and 6 gigahertz. So let's say on your 2.4 or your mainly 5 gigahertz wireless networks, if you wanted to achieve higher data rates and the higher throughput, then what you would need to do is to bond your Wi-Fi channels together. But we kind of had to pay a bit of a price for this, because every time that you bond a channel together, it means that you're going to be doubling the amount of noise that is coming into the channel. So to get the faster data rates and the higher throughput, typically it means that you're going to have to compensate with reducing the quality of that signal. So for example, here on a 20 megahertz wide channel, if we had an SNR of 25 dBs, and then let's say we was to double the channel width from 20 megahertz to 40 megahertz, that means that we are doubling the amount of noise that's coming into the channel. So the noise is going up by 3 dBs. That means our SNR value is going to go down by 3 dBs to 22. Then if we were to double the channel again from 40 megahertz wide to 80 megahertz wide, well, again, we're doubling the amount of noise that's coming into the channel. So our noise is going to go up by 3 dBs, taking it to 6. Then our SNR is going to go down again by an additional 3 dBs. So take it down to an SNR value of 19 dBs. So what has changed with 6E and the power spectral density rules? So basically now, each time that we are doubling the channel width inside of 6 gigahertz channels, we are going to be actually increasing the effective radiated power by 3 dBs to have that offset, so we can keep a constant signal to noise ratio by increasing that transmitting power and that effective EIRP each time that we double our channel width. So we are able to keep a constant SNR value. So no more having to pay a price for achieving those higher data rates and the faster throughput. So the only things to call out here is, depending on where you are, you're going to have kind of different values and different transmitting powers and different rules that you have to play by. So please always do make sure that you check with your local regulatory domain specific for where you are. Now, a question that we kind of get asked a lot, especially when I was back doing my professional services days, is what would a one-to-one replacement look like if I was to just rip out my current access point locations and then install some new access points in those same locations? And this would be a question that we would get asked quite a lot. And in fact, we got told we had to do it quite a few times for some of the customers we were working for, because they didn't want to pay for the additional cost to have a new design done. They didn't want to pay to have the new cable locations being run, because it can get quite expensive. So what they wanted to do when they was at the point of their Wi-Fi lifecycle, when they were ready to upgrade to the next model of access point, they would just simply take down their access points, put up these new ones, and then kind of hope, wish, pray for the best that it's going to work how they intended it to. And unfortunately, in most scenarios, that just wasn't the case. So they were left quite disappointed. But we have an amazing new feature inside of Ekahau AI Pro that I would love to show you right now. So let me just get that right now for you, and then we can show you instead of just talking about it. Here we go. And all right, so let's take a look at this project file that we have inside of Ekahau AI Pro. And now this is a validation survey file, and the reason I know this is a validation survey file is because we can see that we have got these green survey paths here inside of our project file, and we are looking at measured data for all of the access points right now. And if I wanted to filter down to just our stakeholders or the customers' access points, what I would need to do now is change from the all measured filter down to all my networks. And now we are just looking at the results for the signal strength for the customer's access points right now. So let's say that this customer has asked the person to come and do this validation survey because they're really unhappy with the performance of their Wi-Fi. They're saying that they're really unhappy with vendor A, it's just not working how they would like it to, and they've heard that vendor B or even vendor C, they are the holy grail, the savior. They can come in, just rip down these access points and put up their access points in the exact same positions, and it's going to fix all of their Wi-Fi issues. So why don't we take a look at some of the results from this file and analyze how the Wi-Fi is performing right now, and then we can see if we think just simply ripping out and replacing the current APs in their locations with a different vendor will fix their issues. So right now I'm in the Inspect tab of Ekahau AI Pro, and I have selected this position on the floor plan. So we're looking at the primary coverage for this level 3. We've got 4 floors in this project file, and we filtered it down to just the customer's access points right now. And what we can see is that on 5 gigahertz for primary coverage inside of this meeting room, right now we are not meeting our requirements because we don't see any color here. If we had the green, that meant we're meeting our primary coverage requirements. So we can see there's a few areas actually inside of this office over here they're not meeting the primary coverage requirements, but you know, in this meeting room right now they're going to have issues with even just potentially connecting to the wireless for their devices. But primary coverage isn't just all we need in Wi-Fi to have great Wi-Fi. What also that we need is to have secondary coverage. So let's take a look at the secondary signal strength view, and what we can see now is, oh my gosh, there is so much more gray now. So we're meeting our requirements even less for our secondary coverage requirements in even more of the floor right now. And we can take a look at our requirement pass rate up here. We can see just by clicking around on the floor plan the different areas, are we meeting our requirements? So we can see that our secondary signal strength is just not being met in a lot of areas of this file on this floor plan. And why do we need secondary coverage? Well, we need to have good secondary coverage so that our client devices can roam from one access point to the other. It's how they discover other access points that they need to go and associate to as they move around the environment. The other thing as well is, if we were to lose one of these access points, if the cable went down or if the access point had an issue, the redundancy for connectivity in an area would be very, very poor. So there'd be no secondary coverage from another access point nearby for client devices to connect to if an access point was to go down. So if we were to simply just take out the old AP locations right now and put up some new model access points, do we think we're going to fix the issues here just by simply ripping out the old locations and putting in new ones? I personally don't think that it would. If you're at the stage of your life cycle now where you're ready to upgrade your access points, or you're having issues with Wi-Fi, what you will need to do in most situations, 9 times out of 10, or probably even higher, 9.9 times out of 10, is to check to make sure that your Wi-Fi is meeting the requirements for how you want the Wi-Fi to perform today. And that's, in most situations, is going to mean that you need to have a new design done. The way that people want to use Wi-Fi these days is extremely different to how it was going back a few years. So you need to have a new design done. So we can also check our beautiful visualization, which is called the network health, and we get a simple pass and fail. Are we meeting our requirements here? And we can see that we are not meeting our requirements in 71% of our floor plan. So well, let's see what it might look like then to upgrade to another model access point. So I'm just going to go back to this primary coverage view for 5 gigahertz, and the access points that are installed right now, they are not 6 gigahertz capable, so don't have any 6 gigahertz radio, so we don't see any 6 gigahertz data here right now. We have 5 gigahertz and we have 2.4 gigahertz. So if we come back to this network filter right now, we can see that we just have all of this measured data inside of here. So to access the network simulator tool, what you need to do is come over to Ekahau AI Pro, select preferences, and then make sure that you have got the enable beta features tick box checked. Then we're going to hit save, and then what we need to do now is go to actions, network simulator, which will pop up this window. And now Ekahau understands that the current model access points, they are from Ruckus, but I don't know exactly what model access point they are. So it's important that we tell Ekahau what model AP is currently installed. So we need to come into this selection now, and then we're going to simply scroll down and pick the model access point. So I'm going to find it now. And then select the model access point that you're looking for, that was currently involved. And now this is when we can choose which model access point we want to upgrade to. So now we can select the access point that we're thinking to upgrade to. So vendor B, let's for example say that we're going to upgrade to the latest Cisco Catalyst access point, which is this one, Cisco 9136i, and we can choose what channel width we're going to use for 6 gigahertz, and if we want to keep it at the default height for the access point, which I'm happy to, then I simply just hit simulate, press OK, and then what Ekahau is going to do is going to run through every single floor that's inside of the file that we've got our measured survey data, and it's going to start replacing the current model access points with that new target model access point, keeping the exact same location, and show you what it's going to look like across. If you've selected a 6 gigahertz access point, it's going to show you what the results would be across all 3 bands, so 2.4, 5 gigahertz and 6 gigahertz. So we can see, even by upgrading to a brand new shiny 6 gigahertz access point, it's not going to meet the requirements for how they want the Wi-Fi to work. We can click on this details button and expand it, and we can see across all of the floors now the results for the passing rate for the requirements on all 3 bands is still not really what we would like it to be to have a great performing wireless network. And if you're concerned that potentially we've lost our measured data from before, don't worry, it's still here inside of your network filter. We just have a new one now that's simulated for this model access point. We can go back to the measured data and review that, but just remember we've got no 6 gigahertz on the measured one, so we'd come back to 5 gigahertz and it's still there. So let's go back to the generated one for the Cisco 9136. I'm just going to close that right now, and we can see, you know, even on 5 gigahertz or 6 gigahertz, we still have these coverage issues on our primary signal strength. And then how about our secondary signal strength? We still are going to have issues with coverage with our 6 gigahertz, our 5 gigahertz as well. And what this is going to be able to show the customer is that, hey, rather than making that investment and just buying the exact same amount of access points and keeping those same locations, what you should do is have a proper design done and come up with some new access point locations to make sure the Wi-Fi is going to meet your requirements, so you're not disappointed with the upgrade when you come to do it, even if you're going to upgrade to a brand new shiny 6 gigahertz wireless network. But we don't have to just do this simulation on just one model access point. We can run this simulation multiple times. So if you think it's just potentially because of vendor B isn't going to work great here, but how about vendor C? Well, let's take a look. Why don't we try? So I'm going to go to Actions, the Network Simulator tool again. I'm going to select the model of access point, so scroll down to find it. And I'm going to select it, and let's try a different model access point now. So I'm going to try why don't we try the Aruba AP 6 gigahertz access point. So let me just scroll to find the Aruba AP635. Here it is. And again, keeping all the defaults, and just simply hit simulate. OK. And again, it's going to run through all of the floors and the current access points locations, change them for this new Aruba model access point, and then predict and show you what the coverage might look like on 6 gigahertz, as well as on the other frequency bands, 5 gigahertz and 2.4 for the new model access points, and see if we're meeting our requirements. And again, very similar to before, even upgrading to a different vendor, we're still going to have performance issues because we haven't got designed to meet our requirements. So this option can save your stakeholders so much time, so much money and pain from not having to go and physically spend all of that money on the new access points, on the new positions that not new positions, but the install team that have to go up and put up these new access points, the new configuration of the new different wireless controller system, and then be disappointed. We can now show them by simulating what we need to do is have a proper redesign done so we can have great performing wireless networks. So Stu, I'm not sure about you, but the feedback that I have heard and seen so far around on a new network simulator tool has just been so overwhelming, because people are just totally loving being able to discuss and just show their customers, their stakeholders, how likely the rip and replace model is going to perform, rather than having to actually just physically do it. I'm not sure if you've had the similar or same sort of feedback.
Absolutely, because it's when we've did this before when we went from AC right into AC wave 1, wave 2 when we were back in the old days. And when we were different antenna patterns, it's important to note that so a lot of times you just can't rip and replace, and and even though the cabling's there, it should be noted that we're hoping that you have at least a kind of a spooling behind it in the ceiling somewhere, so that you can actually at least move it to a few ceiling tiles down or another room, something. Because every AP is going to be different. The design is going to be different. And this is where the simulator really highlights, are we solving a problem that we've got a current problem, right? So Matt, you've got me to come in and say, still got problems with wireless. I think I need new APs. Can we just replace them? Sure, let's take a look. But maybe that's not going to solve our underlying issue by just replacing it, right? It may be down to location, right? It's like real estate, right? Location. And so you have to kind of figure out where the right place to put them, and because every radio is going to be different. And there's a quote from a friend of mine back, Mr. Holmes. He says, say, Stu, you don't want to be, that radio is going to be different. It's going to be placed out differently, whether it's on 40 or 20 or 80. You got to make sure that it's in that right place, because it's not going to behave the same way.
Exactly. And I just seen a few questions going to the Q&A, specifically around the network simulator. So let me just try and answer a couple of them. So yes, I used 18 megahertz wide for my channel widths on 6 gigahertz. I'll explain in a few slides time why that was. But the question was, can you use different channel widths for the network simulator on 6 gigahertz? And the answer is you absolutely can. You can choose to be doing 20 megahertz wide, 40 megahertz wide, 80s, 160. It's completely your choice. I went with 80 megahertz wide, which I'll reveal why in a few slides time. And the other question was, can you use a network simulator on old surveys that have got survey data captured with the Psychic? And yes, that's exactly what I did. That survey was from quite a little bit of time ago now, probably 2-3 years ago, that I captured with the Psychic. So then I've just run it on an old project file. So
and that's an important highlight too, right, Matt, is make sure you got some Psychic data, because you remember a few months back, you were going through is how to get that data right from the Psychic to get an accurate measurement, and that'll play a little bit later on what we're doing here to get you the correct data numbers, right? So that Psychic data is still valid. Keep it.
Yes.
Use it.
Absolutely. So we're gonna go through a couple of poll questions now. So let me just launch this first poll question. Stu, will you do me the honors of reading it out?
Absolutely. So our first question here is, have you started to design for 6 GHz networks?
Yeah, really interesting to see. Have you started to design for 6 GHz wireless networks? Have you are you doing it using our Ekahau AI Pro? Really excited to see the results here. So we will allow the poll to run for I don't know, give it a few more moments just to give everyone a chance to vote. And then what I'll do is I will stop the poll and then share the results very shortly. So I can see quite a lot of people have voted now. So I'm going to end the poll and then let's share the results. So interesting to see that
Okay.
actually mm, pretty much most people have not yet started to design for 6 GHz wireless networks. We can see that around a fifth people on today's webinar have, and there's still
Mhm.
quite a high percentage that have not. So that was very interesting. So okay, well then let's move on to the next poll question, which is a direct follow-up from this one, if you wouldn't mind, please, Stu.
Excellent. Have you started to implement 6 GHz networks today?
Yeah. So
So,
it'll be
so
very interesting.
I want to know.
Yeah,
Right.
yeah, exactly. So out of the, you know, the kind of like the fifth of the people that are on here now, I wonder how many of them are actually started to implement the
Mhm.
6 GHz design. So that's going to be really interesting. So,
Well,
okay.
I can say that I'm designing at home right now. How about that? I'm designing and I'm just waiting for that EP.
Yeah, yeah. Okay. Well, it seems that pretty much most people have had their chance to vote. So I'm going to end the poll and
Yeah,
then
let's have
share
a
the
look.
results.
Let's
Yeah,
see
let's
what
see.
this is going to be an interesting number.
Hmm.
Okay, so there's some folks actually all right.
Yeah, yeah. So
Excellent.
uh, we are starting to implement 6 GHz wireless networks. So that's very interesting. So thank you very much for taking the time to vote on our poll questions today. So yeah, I'm gonna move on to the next slide, and we're gonna start talking about AP discovery options, and this is particularly challenging potentially for 6 GHz. But before we go to 6 GHz, let's have a quick recap of how our client devices currently discover 2.4 and 5 GHz wireless network. So we have two ways. The first way that I'm going to talk about is the passive option. This is where our client device will go onto a channel and dwell for a period of time to listen for a beacon frame that is coming from the access point. Access points, they will be sending beacon frames roughly around every 102.4 milliseconds. So this means that your client device, it will go onto a channel, it will wait for that beacon. If it doesn't hear it or doesn't hear a beacon that's got the SSID that it wants to associate to, it will then move to the next channel, wait for that period of time, move to the next channel, wait for the period of time until bingo, it hears the beacon and the SSID and the data inside that beacon that it wants to associate to, and then it will start that association process. And you might think that, you know, 100 milliseconds doesn't sound like too long of a time, but if you just think about how many channels we've got on 2.4 and 5 GHz, we've got almost 30 channels there that our devices are going to have to passively go on and wait a period of time to discover a wireless access point to associate to either initially associate to or even reassociate to. And that can be quite a long time in Wi-Fi if you've got to go through and scan all of those channels. Because if you're doing anything time sensitive, like a voice or a video call, you know, once you start to have a delay of, you know, very small amount of time, you're going to notice that jitter, that drop off, or your call may even get completely disconnected. So that is the passive way. How about the active way then? Well, the active way is faster because what the active discovery method is that our client devices, they will go onto a channel and then they will send what's called a probe request. So this way the client device is going into the channel and basically saying, hey, who's out there, what have you got for me? Any of the access points that hear that, they respond, and they will respond with the information that they are providing with the SSIDs, etc. details. And this can be up to 5 times faster because typically it will take around 20 milliseconds for the client device to go onto the channel, send its probe, get the probe request. Has it got that information I want? No, great, I'll move on to the next channel. So that can be a lot faster, but there is a slight caveat, especially when it comes to 5 GHz, because our client devices can only send probe requests on non-DFS channels, which are the channels that are affected by radar. So that means that our client devices, they can send, do our active discovery probe requesting on I think it's around 9 channels on 5 gigahertz, and the other 16, they just have to passively wait for that beacon because of the rules with around DFS. So if you've got a 5 gigahertz deployment and you've got these DFS channels enabled and you're using any time sensitive applications, your client devices potentially could have some drop-offs when roaming because they can't roam that quickly. But there is a kind of savior here, which is called 802.11k, which is something that's called neighbor reports. And what is neighbor reports that can be sent by the access point? And well, you can probably guess it's the access points that can hear their neighbors that are around them, so they understand what channels that they're using. So if I can hear, let's say, 3 of my neighbors around me, I can then inform the client device, hey, actually, instead of going to scan all of those channels, what you can do instead is just go scan these channels, because I know that my neighbors are using these channels, so you can just go scan them and associate quicker or reassociate faster as well. So that's how we currently do it in 2.4 and 5 gigahertz. So why don't we take a look at how this is going to be working in 6 gigahertz with 6E. So just from looking at this,
that chart just like exploded. Right?
I know there's a lot going on here, but just bear with me. I'll work through left to right and try and explain this as quickly and as simply as possible. So first of all, we have this concept, which is the out of band option. So if we just think about now, if we've got a client device that needs to discover a wireless network on 2.4 gigahertz, 5 gigahertz, and 6 gigahertz, you could be looking at potentially around 100 channels it's somehow got to go and scan. And if we thought that was a lot before on 2.4 and 5 gigahertz, well, that's a heck of a lot of channels when you include the 6 gigahertz as well. So there has to be some different methods that we can use to speed this up and make this more efficient, because it's just going to be too much to scan, especially for any time sensitive application. So the first method that we're going to speak about is this out of band option. And this means it's basically being communicated about a 6 gigahertz wireless network to associate to through the 2.4 or 5 gigahertz. And this is called the reduced neighbor report. So what will happen here is inside of, let's say you've got access points that are co-located with 2.4, 5, and 6 gigahertz radios, and you've got the client devices that have got 2.4, 5, and 6 gigahertz radios as well. What the access point can inform through its probe request or probe response or the beacon frame on a 5 gigahertz, it can actually say, hey, I have got a 6 gigahertz co-located radio on channel 101 if you want to associate to me on this channel. So this could be a massive time saver for our client devices to be able to go and associate to that co-located 6 gigahertz radio. So that's the out of band option with the reduced neighbor report. So if we then come to the in band option, which first of all is we're going to talk about the multiple BSSID beacon frames. And if we just go back to say 2.4 or 5 gigahertz right now, if you have multiple SSIDs configured on your 5 gigahertz radio, let's say that you've got 3 SSIDs currently configured on your 5 gigahertz radio, your access point and that 5 gigahertz radio will send out a beacon frame for each of those SSIDs. So you will see 3 beacon frames going out for 3 SSIDs on a 5 gigahertz radio. If you've got 4, 5, or 6, you'll have 4, 5, or 6 beacons being sent out on 5 gigahertz. But with 6 gigahertz, we have this new concept, which is the multiple BSSID beacon frame, which actually puts all of those SSIDs, if let's say if you've got 3 configured, only 1 beacon frame will be being sent out on that 6 gigahertz radio. So all of the SSIDs are kind of packed together in one single beacon frame, which is going to be great because typically the management frames are beacon frames. They're all sent out at the lowest configured mandatory rate, and the more management frames you have going out over the air means the more airtime and channel utilization that you're likely to have. So then we have this option, which now is called the fast initial link setup or FILS. And basically this is a condensed beacon frame, and this is a passive way for our device to discover the wireless network. So our client device is going onto the channel, it's listening for these beacon frames, but what is different here is that this option is only containing some essential information such as the SSID name, the SSID, and just the channel. But the difference here is that it's being sent out every 20 milliseconds rather than every 102.8 4 milliseconds. So it's a lot faster now. So that means that our client devices, they can dwell on a channel for a shorter period of time and then move on to the next channel. So quite similar with the unsolicited probe response option. It is being sent out every 20 milliseconds, the same as the fields, but this time it's containing the full beacon information. So pros and cons here, because it's better that it's faster, but it does mean that there's more management frames being sent out in the air. So that's that option. And then finally, we're coming to the preferred scanning channels, or PSC. And the reason why we saved this one for last is because this is the only method that is allowed to do probing. So a bit like how we was doing the active probing before on 2.4 and 5 gigahertz, we can do active probing on 6 gigahertz, but we can only do it on 15 preferred scanning channels. And the preferred scanning channels in 6 gigahertz are every fourth 20 megahertz channel. So if we take a look at here, starting at channel 5 on 6 gigahertz, it's then every fourth 20 megahertz wide channel. And why is this important? Is because we believe that, especially in 6 gigahertz in the US, where you're getting that huge chunk of additional spectrum, this will be the most popular method for client devices to discover wireless networks. So why is that important when it comes to your designs and configurations? Is because it's very likely that 80 megahertz will probably be your default channel width for these environments. Now, don't get me wrong, there's going to be some cases where you might have to reduce your channel widths down because you want to have a cleaner RF space and less contention, which is completely a viable option. But that might mean that you're going to have to use a different type of discovery method. So it's just things for us to think about, but we wanted to make sure that you was aware of these different options. And we think that the PSC is probably going to be the most likely method for devices to discover 6 gigahertz wireless networks. And on that note, we actually have another demo for you, because we were thinking about 6 gigahertz and how can 6 gigahertz not only benefit 6 gigahertz client devices, but also benefit the other frequency band. So we have put together a little demo for you. So I will just prepare.
Demos.
Okay, here we go. Okay, so in this demo, we're going to be talking about Wi-Fi capacity and how the new 6 gigahertz frequency band can not only benefit all of the newer devices that are 6 gigahertz capable, but actually how 6 gigahertz is going to benefit the older devices that only support 2.4 and 5 gigahertz. So what we have here right now that we can see is that we've got a predictive model built inside of our beautiful Ekahau AI Pro, and we have got a design that is currently meeting our coverage requirements for our primary and secondary coverage. Now, this scenario here right now is, and let's say it's an office that is looking to potentially be upgrading their infrastructure very soon. And right now they have got a Meraki MR56 access point deployment, which MR56s are Wi-Fi 6 capable on 2.4 and 5 gigahertz. They have got no 6 gigahertz radios. And the requirements for the office that we see right now is purely to provide 5 gigahertz only Wi-Fi coverage to their client devices to provide voice and video over Wi-Fi. So let's just take a look to double check to make sure we're meeting our coverage requirements first of all. So we can see that we're looking at the 5 gigahertz frequency band right now on the primary signal strength. And then how about for secondary signal strength? Great, we can see that we've got no coverage issues whatsoever right now. So let me go back to the signal strength view. But what we want to be talking about right now is something that's called capacity. So how many devices are going to be inside of this office floor using the Wi-Fi? And we have got something that's called an area that is drawn right now, and we need to tell Ekahau how many devices are inside of this area and what are the bandwidth requirements for the applications that they're going to be using. So to do that, what I'm going to simply do is just left click on the area here right now, and I'm going to click on this advanced button. So I click on advanced, and what you can see that we've got here right now is that we've got our area floor name, we've got our coverage profile assigned to this area, and then we've got a box here for our devices. And you can see that we've got currently no capacity requirements set. So what I need to do is add some devices. So I'm simply going to click on add devices, and now we can pick how many devices are going to be configured inside of this area. So let's make it 250. And then now we can choose what device type we want to assign to this area. And now this is the time when we would assign the type of device that's going to be being used on your stakeholder that has asked you to do the design for here. And this is where we set for the type of device, if it's Wi-Fi 6, Wi-Fi 5, Wi-Fi 4, how many spatial streams does it support, what's the maximum channel width that it supports, etc, etc. And we have some generic devices configured here, but if you take a look at this and you think, oh, actually, hold on, none of these devices that I see right now fit the profile for my environment that I'm designing for, well, we can configure our own profile simply just by clicking on configure profiles here. And then what I can do is I can click on add. And now let's say that I want to add some corporate Wi-Fi 6 devices, mobiles. So I'm going to call it Corp 6 mobile devices. And now I can choose the technology by simply clicking this drop down, and I'm not going to make them Wi-Fi 6E right now because that Wi-Fi 6E means it's going to be capable of the 6 gigahertz, but we're going to look at going to 6 gigahertz shortly. And so for now I'm just going to pick Wi-Fi 6 2.4 and 5 gigahertz and then select the maximum supported bandwidth for the channel width. I'm going to stick to 80 megahertz wide. The MIMO is how many spatial streams and radios the device will be having. Typically most devices are going to be 2x2x2, so I'm going to stick with that. Offsets, we'll save that for another time, and then band selection I'm going to leave as automatic and simply hit close. So now we have 250 Wi-Fi 6 mobile devices assigned to this area. The next thing that we need to assign is what's called an SLA. So what are these devices going to be doing? So how much bandwidth per device needs to be configured for this area? And again, we can look in here, we can take a look at the ones that are already configured for you to use, but if you see something here or you don't see something here that you think that you're going to be using for your environment, again you can configure your own profile simply by clicking configure profiles, hit add, and then I can call it, let's call it Corp voice and video for now. Keep it nice and simple, and you can either add just one application here, or if you wanted to, you could actually add multiple types of applications. So now we've got a SLA of below 1 meg assigned, and if I wanted to add something else to here, I simply could just scroll down, take a look at the different options right now that I would want to add, and then you can add multiple different types of applications to start to build up your profile for whatever you think suits you best. So I'm going to add the 2 megabits per second, and I'm just going to delete this one for now and just simply hit close, but you can play around with this yourself for however you need to configure your profile. Okay, so I hit close now. So this means that we've got 250 Wi-Fi 6 devices all needing 2 megabits per second to provide good voice and video over Wi-Fi, which means the total bit rate for this area is going to be 500 megabits per second. So I'm going to hit close now. Now that has assigned those devices inside this area. So why don't we take a look at how our performance is performing for our capacity by simply changing to this visualization called the capacity health visualization. And oh no, everything's gone red. And everything's gone red, so it means it looks like we're failing our airtime. But how do I know for sure? If I move over to the inspect tab and I simply click inside of anywhere on the floor plan, you will see it's going to tell us exactly where and why we're having issues. So we've got not enough airtime, because typically with Wi-Fi, only one device transmits at a time. And that's not just true for our client devices, but this is true for our access points as well. So if all of our access points are sharing the same channel, then they're all going to have to play the game and wait to access the Wi-Fi medium themselves as well as our client devices. And you might have noticed here, if we take a look at my design, whoopsie, they haven't done a good channel plan. All of my 5 gigahertz radios are currently on channel 36. So what I need to do is run a channel planner. So I click on this channel planning button here. It's going to pop up this window for us, and we can now select what frequencies we want to do a channel plan for. Because these access points are only capable of 2.4 and 5 gigahertz, no 6 gigahertz right now, we will only have the option for 2.4 and 5 gigahertz. 6 gigahertz is grayed out. There's a few other options we have here, so disable any unnecessary 2.4 gigahertz radios, optimize for mobile devices. I'm going to leave that off for now because I'm just purely focusing on 5 gigahertz. So the frequency band I want to select right now is just 5 gigahertz, which is here. And we have the option now to pick what channels we want to include in our channel plan. You can keep all of them on, but if you're in an area that's heavily affected by perhaps radar activity, you may want to exclude some of the channels, and you can do that simply just by unselecting some of these channels here. But I'm going to leave them all on for now. Then the other option you have is to either use the 20 megahertz wide, 40, 80 or 160 megahertz. From my experience, 5 gigahertz is getting extremely congested now. Tons of Wi-Fi out there, lots of access points. So really, I would probably stick to 20 megahertz wide and 5 gigahertz to try and keep as clean RF space as possible. And what I'm going to do is I'm going to simply hit create a plan. And what happens now, we have a channel planner that runs, and we can see that the planning is now complete. And on 5 gigahertz, we have 100% pass rate for our requirements, which is good. But also our capacity now is passing everywhere with this amount of devices. So that's great. We can see that our capacity is now passing with this amount of access points once we've done a good channel plan and everything is all good. Fantastic. Great. But now let's say that this office environment, they no longer just want to be providing voice and video over Wi-Fi for their client devices. These client devices are starting to get a little bit more application hungry, and they need to have a bit more bandwidth. So perhaps they're going to start using file sharing, AR, VR, who knows, they just need some additional bandwidth. So what do we need to do now? We need to come back into our area and go to the advanced option. And what I'm going to do now is, instead of giving each device a 2 megabits per second SLA bandwidth requirement, I'm going to double it to be 4 megabits per second. So do I see anything in here that's 4 megabits per second? And I do. I see the high SLA. So I'm going to select that now. And you might have noticed that our bit rate jumped from 500 meg to 1000. So I'm going to hit close now, and let's see what happens. Oh no. So now that we have assigned the higher bandwidth rate for those devices, we are no longer meeting our capacity requirements in areas of the floor plan. Because we haven't got enough airtime. So what we need to do now is, let's say that the customer's at a point where, yes, we want to provide some more bandwidth to our client devices. Actually, I'm ready to upgrade my wireless network. I want to upgrade to a 6 gigahertz wireless network, and I'm going to start to upgrade my client devices to 6 gigahertz as well. Fantastic. Cool. So what I want to do now then is I want to change all of these Meraki MR56 access points to be MR57 access points, because they have the 6 gigahertz capability. So what I'm going to do is I'm going to select this quick select tool option up here and simply select all of my simulated access points, which you'll see they now get all highlighted blue. Click on these 3 dots up here and go edit multiple access points. And what I'm going to simply do now is change from the MR56 to the MR57, which does have a 6 gigahertz radio. You get a little warning to say, if you change the model of access point, it's going to make all of your configuration of the access points go back to their default value. So just be mindful of that. So I hit OK. They now change, and we have got a third radio which is capable of doing 6 gigahertz. So I hit OK, and we are failing our capacity again on 5 gigahertz. So what did I just say about the airtime for our client devices and how Wi-Fi works? That if all of our access points are sharing the same channel, that means they have to play the game too. And just like our Wi-Fi client devices, so by going to a different model access point, all of our APs go back to the default channel, so we need to run another channel plan. So what I need to do now is, if I go to the channel planner tool, and this time I want to do frequency bands for all of the bands, just 5 gigahertz. We're mainly focusing on 5 and 6 gigahertz. There's no 2.4 requirements for this office anymore. So now what I'm going to do is, I've got my 5 gigahertz enabled. We can see that I'm going to keep that at 20 megahertz wide, but now we can see 6 gigahertz option as well. And again, you can just simply choose the channels you want to use and the bandwidth you want to assign to your 6 gigahertz radios. Now, from what we learned about the PSC discovery method for our client devices, I'm going to stick with 80 megahertz wide on 6 gigahertz. Then simply I'm just going to hit create and create a plan. And okay, well, we are passing a little bit more for our capacity requirements on 5 gigahertz, but not quite everywhere. How about for 6 gigahertz? Oh no, we don't see anything here. And why is that? That's because I haven't actually configured any Wi-Fi 6E 6 gigahertz devices inside of my area. I left it all on the Wi-Fi 6 only devices. So let me come back to inside my area by left clicking here, going on advanced. And now, remember, the stakeholder said to us that they're not just only upgrading their access point infrastructure to 6 gigahertz, but they're also upgrading their client devices as well to be 6 gigahertz capable. So what I'm going to do now is go add devices, and I'm going to share the load evenly between 5 gigahertz and 6 gigahertz by putting 125 devices on each. So what I'm going to do now is I'm going to select here a Wi-Fi 6E capable device. So if I scroll down, do we see any? We have a Wi-Fi 6E laptop here. So I'm going to select that. That means it's 6 gigahertz. I know, slightly confusing. Wi-Fi 6 is 2.4 and 5 gigahertz Wi-Fi 6. Wi-Fi 6E is Wi-Fi 6 in 6 gigahertz. Okay, and I'm going to assign the high SLA of 4 megabits per second to my 6 gigahertz capable devices. If I can find it, there you are. So now we still have 1000 megabits per second bit rate for the total area, but we are sharing the amount of devices between 5 and 6 gigahertz. So I'm going to hit close and let's see what happens. Wow, okay, so on 6 gigahertz now we see our capacity health visualization, which wasn't there before because we now have our 6 gigahertz devices. If I go to inspect, we can see that we are passing everywhere 100%. But remember on 5 gigahertz, we had that issue around here. Well, let me go to the 5 gigahertz frequency band, and we can see now on 5 gigahertz as well, we are passing our requirements everywhere, which is fantastic. So with the incoming of 6 gigahertz, it doesn't just benefit all of these new devices on 6 gigahertz. They're going to be 6 gigahertz capable by connecting to those 6 gigahertz radios. What that also means is the more 6 gigahertz devices that come along, that means there's going to be more free airtime for those older devices on 2.4 and 5 gigahertz to connect to those radios. So 6 gigahertz is going to be hugely beneficial, not only for just the 6 gigahertz devices, but also those other devices as well. So that's what we really wanted to show you with this demo today. And yeah, I just saw a really good message pop up in the chat about the green diamond, and your client device always makes that decision about what frequency to choose and SSID. So we was really kind of thinking of that. And yeah, our next question that we had in our heads was that should we use the same SSID across all 3 bands? And to kind of answer, the question that someone just put, or the statement that someone just put in the chat is, it's always down to the client device for which access point is going to associate to. And if you've got a same SSID across multiple frequency bands, it's down to the client device to choose which one it's going to associate to. So the only way you can kind of guarantee what frequency band your client device is going to associate to is by having single band SSIDs. And with 6 gigahertz, it's not just all of these other new features we've got to think about, from AP discoveries, what channel bits should we use, but also security as well will play into the answer of should we have the same SSID across all 3 bands. So if we just take a look at Wi-Fi security very quickly, we've got open, which is open encryption, no authentication, typically used for guest wireless network. So if you're associating to that, you'll be careful of what you're doing because you're given no over-the-air protection. And then we have WEP, so the wired equivalent privacy, which again, hopefully no one on here is using on any of their deployments because it's not too secure. So we don't want to be using that. Then we have WPA, again, which is very old now, very legacy. We don't want to be using that because not only is it not that secure, it's also very slow. So you're limited to 1 spatial stream and a maximum of 54 megabits per second. So hopefully none of us on here are using this or being forced to use this for any of our deployments. And then we get to WPA2, which is what we're probably the most familiar with personal and enterprise. So personal is your pre-share key that you input into your devices to associate to wireless networks, and enterprise, which is 802.1x. Still very popular method of security. But then we also have WPA3, which has come out fairly new, which is actually going to be mandatory in the 6E, 6 gigahertz. And the key thing here is that this actually enforces something called management frame protection, or protected management frames. So why is this important? Because if you had just one SSID configured across all 3 bands, that means you're going to have to basically enforce pretty much WPA3 or transition mode. And if you have older devices that don't support the WPA3 and you put it as on, then they're just not going to be able to associate. So there's some things there that we seriously need to consider. With the authentication for WPA3, we no longer use PSK, it's SAE now, which effectively just makes your devices less susceptible to offline dictionary attacks. And like I said, yeah, we've got the enterprise.1x still, and we have the option to have it either on or in transition mode. So the big thing here is the protected management frames, or management frame protection. It depends on what vendor you use or how you like to use it. We thought we'd throw in both options to make sure we cover all bases. But the big thing here is that this is mandatory in 6 gigahertz. So why I want to put it in here is because we wanted to think about how would we start configuring some of our SSIDs. So everything that you see in white right now, that's what we're saying that we anticipate will be SSIDs. Now, don't get me wrong, this isn't going to be right for everyone, but this could be like a good base or good start. So 2.4 gigahertz, where do we see that fitting in the future? And really, if you're just worried about legacy client devices coming into your environment, then you might want to have a guest legacy SSID that's 2.4 gigahertz only. Using WPA version 2 for pre-shared key and sticking to 20 megahertz wide channels. And for your IoT, so your lawnmowers, hoovers, fridges that are connected to the Wi-Fi, whatever they are, they're most likely going to be using 2.4 gigahertz. So you'll be using that for those IoT devices. And then we wanted to come up with a really original name for SSIDs, for single band SSIDs for 5 gigahertz and 6. So we come up with Guest 5, Corp 5, Guest 6, and Corp 6 to differentiate between SSIDs. I'm sure everyone on here can come up with way better names, but why do we think that having single band SSIDs is probably going to be the most popular method for configuring your SSIDs, especially in the US? Well, that's because there's going to be a bit of time for all of these new devices to come around, and you're going to want to connect your 6 gigahertz client devices to your 6 gigahertz wireless network and use the latest form of security. And they'll be using probably 80 megahertz wide channels, especially in the US. But then you're going to have some devices that are not 6 gigahertz capable, can't support WPA version 3. So then you probably want to connect them to your 5 gigahertz only SSIDs. And I've seen some validation survey files of deployments in the US, and especially here in the UK as well. As the 5 gigahertz wireless networks, they're getting extremely congested right now. So we probably don't want to be using the wider channels on 5 gigahertz. We probably want to stick to 20 megahertz wide channels to keep that cleaner RF. But because we've got such a huge chunk of additional 6 gigahertz spectrum and the preferred scanning channel method of AP discovery for our 6 gigahertz client devices on the 6 gigahertz frequency band, that's what we kind of anticipate will probably be something that we would do for our configuration. And then we just wanted to throw a slight spanner in the works and think about how this might work for in Europe, or if you have got a really high density deployment in the US potentially, where you really want to leverage all of those 6 gigahertz channels, but have a lot of frequency reuse because you're doing a very, very large high density deployment where you might not want to use 80 megahertz wide channels. Well, 2.4 gigahertz, same story here around guest legacy and IoT. But if you're guest and corporate SSIDs, you might actually have 5 gigahertz and 6 gigahertz configured on the same SSID. And the reason why this might be because you may be using the out of band method, where you're using that co-located reduced neighbor report to inform the client device about your co-located 6 gigahertz radios, and using a smaller channel width to give you that more frequency reuse in your 6 gigahertz spectrum in your deployment, because you've got a very high density deployment that you need to think about. And for us over in Europe, we're only getting 500 mega, I say only, but still good, not as good as the US, but we're getting that 500 megahertz of additional spectrum to use. So it's not as much spectrum. So we might not decide to go and use 80 megahertz straight away. So we might be using 40 megahertz wide and 6 gigahertz, or even 20 megahertz wide and 6 gigahertz. And then enable WPA3 in transition mode. So what that means is if you have WPA3 capable devices that come along, they're able to connect and use WPA version 3. But if you don't have WPA3 clients, like say WPA version 2, they'll just come along and they'll use WPA version 2. So we wanted to finish with some examples for some configuration. Of course, please make sure you make it relevant for your deployments and for where you are, but we wanted to give you something to take away potentially. And finally, please make sure you're registered for our next upcoming webinar, where we're going to be unboxing the future of Wi-Fi. It's going to be,
I can't wait.
I can't wait.
Can't wait. That's so mark your calendars, folks, for Thursday, July 21st, and make sure you sign up often.
Yeah, yeah, exactly. So make sure that you're signed up, and make sure that you are registered for our upcoming webinar. It's going to be a big one. We're really excited, and we hope that everyone can be there. It's going to be on Thursday, July 21. So yeah, make sure you're signed up, and we yeah, that's comes to the end of the webinar today. So Stu, I'll fire over to you to see if we've got any questions that we want to
you know,
answer.
we had and thank you for everyone who's actually joined us today. And I know we're at the top of the hour, and so if you have to go, don't worry, and that kind of we will close out the webinar there. But as we go into kind of into kind of our questions and figure out, you know, what are some of the kind of the hot ones, is a lot of folks out there are talking about that. How am I going to, you know, the transitioning, right? As I'm going to be able to roam between those the two networks, between a WPA2 and WPA3. And I think Matt, you know, it's going to depend, right? I mean, we're on the client type and capabilities. I mean, we're getting into some complex things now.
Yeah, exactly. And different, we need to remember that different vendors may be implementing this in different ways, that you may only be able to have WPA3 enabled on your SSID. So that may force you on having two different versions of that SSID anyway. So yeah, so depending on the vendor you're using, you know, you may have to have multiple versions of SSIDs because of the security, because you want to have people just associating on 6 gigahertz. You might be using different discovery methods, where you're using the out of band discovery to, you know, use that co-located radios inside of an access point on the 5 gigahertz beacon or probe to then associate to 6 gigahertz. There's a lot to unpack, and that really is why we're doing our Summer of 6E, because there is so much to uncover and go over. And yeah, so we'll be continuing on, and really looking forward to our next one, where we talk about step 2 validate. So yeah.
Absolutely.
And you managed to find a shirt
I did, right?
I didn't even
magic.
notice.
I got
Wow.
the wardrobe right here, so I just can grab something. So, so I figured, okay, I got to join you on that. So yeah, no, it's you know, the big surf is here, right? And it's time to really ride that wave. And we are in an inflection point on all of our careers, where we're adding something completely new. You know, this is something that, you know, of course, 6 gigahertz has always been there, right? It's a band that's always been there forever, but we're able to use it as Wi-Fi folks, right? Now we can kind of like, ooh, this is a new shiny object. We can actually expand our networks. We can actually have those needs, speeds and feeds, right? We can be more efficient, right? I think you've heard this. We have to be more efficient in our networks, and we've been banging our heads on the table when we have like these massive amounts of folks in venues and whatever, and you're trying to make them more efficient. And like, well, how do we do that? Well, enter 6, right? Enter WPA3 has got to be the biggest change or piece, right, for all of us. And that comes into a question. Someone asked, will the amount of SSIDs still be the, you know, matter, right? I mean, you know, for me, I'm always keeping it as low as possible per band. And I think you're probably on the same wavelength as me, is don't overtax so many, because it adds to that overhead, right?
Yeah, so
Yeah, what do you
we
think
do
about that?
Yeah, so well, in 6 gigahertz, we do have the multiple BSSID beacon frame, where the multiple SSIDs are now contained inside of that one beacon frame. So it doesn't really have the same kind of implications as it did in the 2.4 and 5 gigahertz, where it's creating a lot of additional management overhead and eating up some of that airtime. But again, really, I agree, we probably want to be limiting your SSID. So probably 3 to 4 per frequency band is kind of what I've always stuck to. And I imagine that's probably what I'll be sticking to in the future as well, to cover your IoT, your guest networks, your corporate, maybe laptops, and then your corporate mobile devices. So that's kind of how I've always kind of been doing it. And you know, creature of habit, probably be doing it the same until, you know, we get to really play with it and deploy it and think about it in the real world. As that may change, but for now I would be limiting my number of SSIDs to the same amount of that I've always used and proven and worked before in the past as well.
Well, it also comes into management, right? You don't want to be managing so many different ways to get into your network. Is
Yeah,
keep it simple.
exactly.
As
And
one
if
fellow you would always
one of
tell
the
me, right? Keep it simple, Stu. So yeah, no, for sure. And then that comes into kind of, you know, like, you know, but even open guest SSIDs, right? Is we've got a great question, you know, is there any mandatory changes between the bands? And I think this is not, you know, it's open or open enhanced. I mean that we're getting into
yeah,
more complex pieces there.
yeah, in that's correct. So enhanced open, which uses OWE, which offers some more encryption there. So that's also mandatory in 6 gigahertz. So that's a great point to bring up. So that'd be something else for the potentially like guest open networks that you have. So to offer a little bit more of
Mhm.
encryption, it doesn't quite do the full packages, but it's it's definitely better for sure.
Yeah, for sure. I mean, obviously, you know, it's a changing ever world, right? It's our technology changes by the week, by the month, or sorry, by the hour, and sometimes even by the second. And so it's we're constantly learning, folks. And one of the goals of our webinars here, you know, that the team help we all put together is try to kind of arm you with as much information as we can to make those important decisions and use the tools to help you enhance that process, right? And so and then stay tuned for us to kind of eat and enhance more of this. And as more things develop, we tend to put more of that into our products. And always, as Matt says, always keep the feedback coming. Like, please, it helps on the development of what what you want to see as we're making the product for you, right? We want to make sure that it's working.
Exactly. And let us know, do you want to see some more of these shirts? We can
Yes, I do.
keep these coming
Yes, I do. We have
across
another
the
second. Yes, we do. Let's do it.
more shirts. All right. Well, I think we'll wrap that up for today. Then we will see you all hopefully on the next one. Thank you so much for being here, for everyone on the webinar today and everyone else at the wider Ekahau marketing team. Lots of love, and we will see you all on the next one where we've got a very exciting webinar. Tell your friends, family, dog, work people, everyone. Be there or be square. So we'll see you on
That's
the
right.
next one.
We'll see you then.